Hi. So in this video, we're going to look at how to work with discrete random variables. And I'm going to use this example to explain what this means. So we're told that two spinners, spinner A given here and spinner B, are both spun. And the product of the spins is recorded. For part A, we've been asked to use a sample space diagram to record all the possible outcomes. So if we create a two-way table showing all the possible outcomes for spinner A, which are 1, 2, and 3, against all the possible outcomes for spinner B, which are the same, then we can multiply these together to find their product. So if we get a 1 on spinner A and a 1 on B, the product will be 1, and then 2 and 3, and the same going down. If we get a 2 on A, a 2 on B, we're going to get a 4, 3 and a 2 will give us 6, and then a 3 and a 3 will give us a 9. So the reason we're looking at discrete random variables is that the outcomes can only be particular values, any of these. We can't, for instance, have an outcome of 2.5 or 1.06. So it's discrete because it only allows particular values. And for the random variables, well, this will be the product of each of a spin. So we could get any one of these variables at random. So in this case, the random variable would be the product of a spin. So I hope that explains the phrase discrete random variables in this situation. For part B, complete a discrete probability distribution table. So if each of these outcomes are our random variable, we can call this x, because the outcome could be unknown. So our table would be the observed value, little x, against the probability of our random variable being that observed value. So when x is 1, you can see we've got one outcome out of a possible 9. So our probability for x is 1 will be 1/9. When the observed outcome is 2, you can see we've got 2 of them, so 2/9. When x is 3, we've got 2 of them, so again 2/9. When x is 4, we've got 1 of them. And then when x is 6, 2/9. And when x is 9, the probability will be 1/9. So you can see that this table shows how the probabilities are distributed. And an important property here is that the sum of the probabilities add up to 1, which makes sense because it is certain that one of these outcomes will occur when you spin each of these spinners. Okay, so for part C, to find the expected value, we write this as the expected value of our discrete random variable x, and this is the mean or the average. And what this means is, if you were to spin these lots of times, so you've got a large sample size, and then to find the mean of these observations, this value will get closer and closer to the expected value. And we can work out this expected value by finding the mean of this table. And we can treat this like a frequency table, where the mean would be one lot of 1/9 plus 2 lots of 2/9 plus 3 lots of 2/9, and then we'll carry on adding the product of each of these. So then we can work out each of these products and then add each of these together, so we get 36/9 or the expected value of 4. Okay, let's try another example. So in this question, we're told that a 7-sided spinner has faces 1 to 5, and the random variable x represents the score when the spinner is spun. For part 1, we've been asked to show a probability distribution of x. And then for part 2, to illustrate this distribution, and then for part 3 to work out each of these. So do you want to try and work out part 1 yourself? You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. So if we let our observed value be little x, and we want the probability of our random variable big X equaling our observed value. So when x is 1, we've got 1 out of 7, when x is 2, we've got a probability of 2/7. When x is 3, 1/7. When x is 4, we've got again 1/7, and when x is 5, we've got 2/7. And then for part 2, to illustrate our distribution, we can use a stick graph. So when x is 1, we'll have a vertical line up to 1/7. When x is 2, when x is 3, when x is 4, and x equals 5. And then for part 3, we can use either our distribution table or our stick graph to work out each of these. So for part A, probability of our random variable being greater than or equal to 2, when this will be when x is 2, 3, 4, or 5. So rather than adding up each of these, we know their sum is 1. So we can say this will be 1 minus the probability that x equals 1, which will be 1 minus 1/7, so 6/7. Part B, the probability that x is odd will be the probability of it being 1, 3, or 5. So we can add up each of these, and we get 4/7. And for part C, the probability that x is greater than 5 is 0, because you can see that 5 is our biggest number. And then for part D, the expected value of x. So we'll work out each of these products, and then we'll add them together. So we can work out all of this, and we get 22/7. So this would be our expected value, okay? So I hope that's given you an idea on how to work with discrete random variables. If you did find that helpful, please like and subscribe, and you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.